scary. Big word. Okay. So derivatives are basically, I'm going to write it down. The slope of a function at a certain point, or also the rate of change. So you might say, how do you find a derivative? Stop! So there's multiple rules with finding derivatives. So there's the constant rule. Woo! So fun. Okay. So basically, it's when the derivative of a constant. So like the derivative of any constant, no matter what number it is, big or small, it's going to equal 0. F of x, which f of x is equal to like y in any equation, is equal to 20, then the first derivative, which is, this is how you say the first derivative, is equal to 0. So, can you guys guess what the answer will be for the next question? 0. Woo! 0! So, okay, to explain it, this might help. So when you graph y equals 3. So at y equals 3, right here. So the slope of this line is what?
0.
Exactly. So that explains when you take the slope of an equation where it's just like a number, when y equals 3 or f of x equals 3, because that's the same thing, it's going to be 0. So next is the power rule. Woo! Usually in AP Calculus you learn like the formal definition of a derivative, but this power rule is like the cheat sheet, and once you get used to it, it's what you use all the time. Basically the power rule, it's, I'm just going to write the equation. So it's n, which is any number, x to the n minus 1 power. So if f of x, or y, equals x squared, so this is what you're going to do. Basically what that equation I just wrote before is you take this 2 right here.
That's the n.
That's the n. And then you move it down here in front. Basically you're multiplying by whatever's in front. And then you subtract 1. That's where the minus 1 comes from. So the derivative will be 2x. Because there's a 1 right here, so 2 times 1 is 2, and then you subtract 1 from 2 and you get the power of 1. So you could write the 1, but you don't have to. So if the next one, f of x equals 100 x to the 5th, then f prime of x equals, okay, does someone want to tell me how to do it? Allie, you got this.
Want to go for
Okay.
it? So you do 5 times 100 to get 500.
Yes.
X, and then you do the 5 minus 1, so you get x to the 4th power.
Yeah, woo! Solid. I'm so proud.
Okay. So you can use derivatives to find the tangent line. Do you know what a tangent line is? Yes? Does Allie want to explain?
Oh, no, I knew. It intersects the circle at one point, right? No?
Yeah.
Yeah?
It meets the, okay, so it says draw the tangent line at x equals 1. So you have this graph and a circle. Really ugly circle. So where would the tangent line be at 1? Does someone want to draw it?
Yes.
No?
Sure.
Okay.
Come.
Okay. There's 1, right? It intersects
Yeah.
there. And that's going to intersect there. Like that.
Perfect.
Yeah.
So, how do you find this line? you have to find the slope of this particular point where it intersects, and that usually you find slope by y2 minus y1 over x2 minus x1, but because we know calculus, we can find the slope using the power rule. F x equals 4x squared. Then what is the equation? So the first step is to find the derivative of fx. Do you know how to do that now? Shout out an answer.
8x.
Yes, go Monica.
Woo!
Okay. The second step is to plug 2 into that equation because we're trying to find the equation of the tangent line at x equals 2. So what would that be?
16.
Yeah. And now that's the slope at x equals 2. And if you remember the point slope equation, you can just plug that in as y equals 16 x minus, and then we need to find this plus the y value. So to find the x and the y you plug in, you find the tangent point. And that's really easy. All you have to do is plug 2 into the original equation, fx equals 4x squared. So if you do that, f of 2 equals 4 times 2 squared. What do you get?
16.
Perfect. So now you just plug that in, x minus 2 plus 16. And that's the equation.
So next we have, this is what I was talking about, the second derivative definition. So that's just when you take the derivative, or when you derive an equation twice. Sorry, I forgot to write equation. And it's represented like this. The amount of apostrophes here determines what derivative it is. So we're going to do a little bit of second derivative practice. If f of x equals 2x, so what would the first derivative be? So what would the second derivative be? Nice! Woo! That's the constant rule. Good job, guys. Now we're gonna do how the derivative applies to like real world problems. So x of t, when it gives you x of t, that means the position at a certain time. And time is equal to t. So does that make sense? Okay. Next, it'll give you v of t. And can anyone guess what that is, physics people?
Velocity.
Oh, yes, it's velocity. At a certain time. Or t. Yes, this is God for yeah, you want to guess?
Acceleration.
So a of t equals acceleration. Let's see if I can fit it all. And then you know at a certain time t. Okay, so now you're probably wondering, what does this have to do with derivatives? Take the derivative of a position. Ooh, fancy. You actually get velocity. Yeah. So like in an equation of position, if you take that derivative, then you'll get the velocity equation. Pretty nice. And then once you get that velocity equation, you can take the derivative of that again, which actually, in fact, derivatives, you can take it as many times. you can take a derivative as many times as you want. So when you take, and you can tell by how many derivatives are taken. Here, I'll go to the next page. When it gives you like how many apostrophes there are. So this would be like the fourth derivative. So that means you take the derivative once, and then you stop, and you take the derivative again, stop, take it again, and then take it again. That's just a side note. But anyways, when you take the derivative of velocity, you get acceleration.
Can anyone guess what the second derivative of position is?
Yeah. So he was getting a little jealous. So this was the equation. Okay, did anyone figure out what the velocity would be?
Okay. Alright.
I keep writing X's. Sorry guys.
Okay.
Yes! Good job! For the velocity at t equals 6 seconds. Did anyone solve for that? Yep, that's correct. So now, in order to find acceleration, you're going to take this equation. So v at t equals 4/3 t plus 8. Okay. So does anyone know what the acceleration equation would be?
It's really stupid. But is it just 4/3?
Yes.
Yeah.
Nice! Nice!
Put your troubles aside, start living. Anybody can let go. Throw away all your problems, 'cause right now it's party time. Girl, don't feel out of place, 'cause I'm in love with this feeling now. I hope that this will.
It's hard.
Don't worry, this is not on the quiz.
Yes, it's not on the quiz. Don't worry about it.
Now everybody put your hands in the air, say yeah, yeah, yeah. Girl, I wanna, yeah, yeah, yeah. I wanna see you tonight, yeah, yeah, yeah. Girl, I got
Woo. So fun.
Woo!
Yeah! Woo! Solid.
I'm so proud.
Yeah.
Shout out again, sir.
Yes! Yes. Perfect! Nice!
bass sound. Oh, sometimes I get a good feeling, yeah.